This call is now being recorded.
Hold on a second. Alright, so here is the notes for your chapter 6. So if you have already looked for it, it is quite a short chapters lah. Okay, we have 6.1, 6.2, 6.3. Okay, so today we are going to enter your chapter 6.1 and half of your chapter 6.2. Okay, so for your chapter 6.1, we will begin with the dynamic equilibrium. Okay, it's quite an introduction about what is a dynamic equilibrium system, what it means by dynamic equilibrium, or what it means by chemical equilibrium, or maybe just the words equilibrium. Okay, so the learning outcomes over here, we need to explain what it means by reversible reaction. Okay, what it means by a dynamic equilibrium, and what does it refer for a law of mass action. Okay, you need to know about their characteristic. Okay, so that characteristic of a system in equilibrium. Okay, and then we want to interpret also the curve of concentrations reactant product against time for a reversible reaction. So how reactions proceed using a curve or using a graph. Okay, so first of all, let's look at the reversible reaction. Okay, so reversible reactions over here, it refer to the words reversible itself. Means that a chemical reactions can take place either in both, either in forward direction or reverse directions. So if you still remember, normally how do you look at one chemical equation? It would like this: A plus B, the reactant A and B, and then you're producing C plus D. So C and D is your product. So this is the reaction where we call a irreversible reaction. So that means you only see a single arrow, one directions only. So whenever you're producing C and D as a product, you'll never get back to A and B. Okay, but therefore reversible reactions, that means when you producing your product, the product can also producing reactant at the same time. Okay, so the words reversible lah, forward can, reverse also can. So we're looking at these examples over here. Calcium carbonate. Okay, so when it decompose, you're going to get the product calcium oxide. Okay, and also your carbon dioxide as the product. But at the same time, when you got your calcium oxide and carbon dioxide, both of these product can also react to get your calcium carbonate. So forward can, reverse also can. Okay, and remember that we are using this symbol. So normally you're using a single-headed river, right? So now we have both directions. Forwards, you're using the arrows going to the right-hand side. So forward, it means from the left to the right. But please make sure that we are only using a half-headed arrow. Okay, separuh kepala saja dekat sini. Okay, half-headed arrows only. And then when you refer to backwards or reverse reaction, that means the reaction process from the right to the left. Okay, so going towards the left-hand side. So until this part, everyone can follow. So madam will always check out to make sure I'm not talking alone.
Can.
Okay, boleh faham ya? Okay, untuk reversible and also irreversible reaction. So whenever you see the question, no, not it's not necessary to tell you that it's a reversible reaction. You have to take notes on the arrow. So setiap kali kalau nampak arrow ini, maksudnya dia reversible. Okay, so when you have a reversible reaction, you will reach one point where the system is already at equilibrium. So that means the forward reactions occur at the same time as the reverse reaction at the same rate. Okay, so over here you have 3 points. Okay, so for dynamic equilibrium, this is the three characteristic. If you want to know whether a system is it in equilibrium, you look at three of these points. So first of all, we look at the concentrations or the partial pressure. Okay, so concentrations or partial pressure of reactant and product remain constant or do not change. Bukan maksudnya dia reaction stop, dia masih ada lagi, cuma concentration dia remain constant or do not change over time. If you see partial pressure, we normally refer to gaseous species. So only gaseous species you're going to have the pressure. Okay, so this is the first point where we say concentrations remain constant. I'm using a short notes over here for you to remember lah instead of sentence. So concentrations, either reactants or products, remain constant. Remains unchanged, do not change. Okay, so the second point over here, we have the rate. So just now we said reversible, we have forward reaction, we have reverse reaction. So the rate happen at the same time. Okay, rate of forward reaction equals to the rate of the reverse reaction. So that is the second characteristic. Okay, so if you want to jot down your short points also can. So rate forwards, okay, equals to the rate reverse. It doesn't mean that the reaction stop, but reaction tak berhenti. Dia masih berlaku lagi tapi dekat rate yang sama. And then the third point over here, the third characteristic, your reaction quotient, which is represented by a symbol Q. Okay, quotient now represented by Q is equals to your equilibrium constant K. So we will talk a little bit more for Q and K in our 6.2. So the third characteristic over here, when you see Q equals to K, it means that this system is already in equilibrium. So setiap kali awak kena check lah kalau dapat tiga karakteristik ini, maksudnya sistem ini adalah dalam equilibrium. Is everyone alright? Is everyone good? We begin with a very simple theory first, yeah? And then a little bit later we will do some calculation. Okay, so looking at this example, so A to B. So if you're looking at this simple equation, this is a reversible reaction. Can you tell me which one is a reactant? Which one is a reactant? If I have A towards B, which one is a reactant?
A.
A. And then proceed, product will be B. Okay, so A towards B, your four reactions. If your reactant is B, okay, for product B back into the reactant A, that is the reverse reaction. So if you look at this curve, okay, we have the graph concentrations against time. Okay, so looking at this point, this is the starting. Nothing happened yet. The very beginning of one reactions. So as time equals to 0, reaction is not yet begin. We have 0 concentrations for the product B. So awak dekat sini akan nampak, okay, product B memang tak ada lah concentration. So line purple ini adalah untuk B. Okay, but then at time t, you will see there is some concentrations for my A. So let's say I put some values over here, let's say 1.5 molar or something else. So there is some values for the concentrations of your reactant A. Okay, so when times goes by, okay, your concentrations of reactant A will decreases because reactions happen. Okay, so concentrations of A decreasing over time until one point, time t, the concentrations of your A remain constant. So that is the characteristic of the first point just now. Okay, concentrations of A remain constant. Okay, so at the same time, your product B, when the reactions begin, From time to time, the concentration increasing, increasing, increasing until one point it will become steady and constant. So we say the concentrations of B remains constant after time t. So this is the line, your time t, the dot line over here. That means until this point, the system is already in equilibrium. So sebelum line T1 ini, sistem belum lagi equilibrium. So awak nampak Q tak sama dengan K. But after time T, the whole system become equilibrium already. Your Q will equals to K. Your rate forward and rate reverse is equal. And then the concentration of both A and B remain constant. So this is the characteristic of three of those. So if you want to look at the sentence over here, also explanations is given. So based on the graph, concentrations of A. So I just want you to take note. Now the square brackets over here refer to concentration. Boleh jot down, square bracket refer to concentration. So in the explanation, also you can use the square bracket. So concentrations of A decreases while the concentrations of B increases with time until time t. After time t, concentrations of A and B remains unchanged as the rate forward and rate reverse are the same. At this point, the system is said to achieve the chemical equilibrium. Okay, achieve dynamic equilibrium, achieve equilibrium. So tiga-tiga perkataan ini maksudnya equilibrium system lah. Okay, so until this point, is there any questions?
Madam,
Yes.
Three of the syarat must be fulfilled to for a reaction to be set equilibrium.
Yes.
Alright.
It's kind of like it's not exactly a requirement, but when you see three of this point, that means it refers to an equilibrium system.
Okay.
So Madam will show you another two more graph. Maybe you want to sketch somewhere around your notes, huh? So this is one of the graph that can show the dynamic equilibrium. But it's not necessary to show you that okay, concentration product dia mesti lagi tinggi daripada reactant. Tak semestinya. Okay, contoh dekat sini. Let's say I still using A and B. At time 0, I have my concentrations B at 0. But maybe I have some concentrations of A. At starting I only at A, I don't have B. So saya boleh juga buat macam ni. Okay, so from time to time, the concentration decreases. Okay, and then at the same time, when the reactions occur, concentrations of ini A concentrations of B berlaku juga. Okay, dia naik sampai point yang sama. Okay, so that means this one is my time T. So A, B. Boleh juga macam ini. Sebab pada masa time T juga concentrations of both reactant product, they are the same. Rate is the same. Q equals to K. So you can see three of this characteristic over here. So over here also Q is not equals to K lah. System is not equilibrium yet. Okay. Lagi satu contoh masih sama lagi A and B. So let's say over here about reversible reaction, right? So maybe I have some concentrations of A over here decreasing with time. Okay. Dan saya juga ada sedikit produk B. B dia tak semestinya kosong. So let's say I start my B over here. That means at time 0, I have certain concentrations of my product B. So B will reverse the reactions back into reactant A. So boleh juga, tak ada masalah. Dan bila dia naik, so this one is my A, let's say. This one is my B. Okay. And then until certain point, the concentrations become constant. Q equals to K. The rate forward equals to rate reverse. So three of this curve, they all fulfill the characteristic of an equilibrium system. So you can see, as long as you can see three of this point, then this system will be said is said to achieve the equilibrium. So tak semestinya concentration dia sama ataupun lebih banyak daripada satu lagi. Okay, so dia hanya kena fokus concentration dia constant sahaja. Dia tak semestinya sama lah. Okay, do you get what I mean over here? This is the second curve. This is the third curve. So three of these example all represent equilibrium system. Okay, is there any questions?
So madam, so it doesn't matter if it's be like the second, it would be like second or not, as long as both of them are already horizontal, it's already considered as equilibrium.
Yes, when you got the horizontal line, that means the concentrations or the partial pressure remain constant already. So dia tak kisahlah concentration atau partial pressure dia berapa banyak, siapa lebih banyak ke siapa lebih sikit, tak kisah asalkan dia constant.
So for the second diagram, it means that both already completely reacted.
We won't say completely reacted, but the reaction is keep on going. Okay, the reaction is keep on going. That's why we said the rate forward equals to rate reverse. Remember,
Alright, madam.
reaction doesn't stop. So catat sini boleh. Boleh catat sini. Okay, reaction does not stop. Do not stop, does not stop, whatever. Keep going. So you will have the rate forward, rate reverse. Kalau reaction stop memang tak ada rate dah. Tapi kita memang ada rate, so maksudnya reaction dia tak ada stop dah. Okay, everyone's good, yeah?
Yes, madam.
Okay, so we continue for the last one of our 6.1. 6.1 is actually an introduction to let you know what is equilibrium. Okay, we're focusing more on 6.2 and 6.3. Okay, so the last one, law of mass action. The definition slightly longer, yeah? So we go words by words over here. So for a reversible reactions at equilibrium and constant temperature, there is a certain ratio of reactant and product concentrations. And this ratio, they will have a constant value K. Remember just now we said the K is your equilibrium constant. And it is a capital letter K, yeah? Capital letter K, equilibrium constant. So law of law of mass action refer to a equilibrium system. Dia mesti dalam equilibrium. Okay, dia mesti untuk reversible reaction. So ratio has a certain value. In another words or a second definitions to define this law, it will refer to the relationship, okay, between the chemical equation and the expressions of your equilibrium constant K. Okay, so you can either use either both of this definition to describe law of mass action. So either the ratio has a certain value or it refers to the relationship between chemical reactions and the K expression. Okay, so we look at these examples over here. So this one is kind of like a general example, yeah? So at equilibrium, let's say we have reactant A and B. Okay, and then it proceed to C and D as the product. So forward reactions AB towards CD. So this arrow refer to a reversible reaction. So the small letter A and B, C and D is the stoichiometric coefficient. Biasanya awak akan ada, let's say I have N2 gas, I have H2 gas, and then producing NH3 gas. So over here, when you balance it, you will get your ratio, you will get your stoichiometric coefficient. So A, B, C, D huruf kecil lambangkan awak punya stoichiometric coefficient. So to explain the law of mass action, to describe it, we want to write the expressions of this K. Okay, then you will see down at the bottom here, we have one formula of, we have one expression. So all of this expression depends on the balanced chemical equation. So gonna make sure this one is balanced. Okay, so the K expression written like this. K equals to the concentration C. So we will have the concentrations of the product sitting on the top, concentrations of the reactant at the bottom. So following the equations, we know that C and D is our product. So letaklah C to the power of C, D to the power of D. Stoichiometry coefficient kita letak sebagai dia punya power. So C to the power of C, D to the power of D, A to the power of A, B to the power of B. If looking at A, B, C, D, it's slightly difficult, but madam show you one example using the N2H2 and H3. Can you try to help me to balance this equation first? How am I going to balance the equation here?
3H2.
2H2?
3 kan? 3.
3H2 lagi?
2NH3.
2NH3.
2NH3 and
1 and 2.
1 and 2. So 1 we don't have to write over there lah. So we have nitrogen gas, hydrogen gas 3, and then ammonia gas. Everyone's agree?
Agree.
Agree, yeah. Okay, so if I want to get the K expressions over here, so K, who is the product in this case? Sorry, let's say I made a salah buat dekat sini. Reversible reaction. So who is the product?
NH3.
Okay, so let's say we want the concentrations of ammonia gas. So the stoichiometric coefficient 2, we raise it to the power 2. And down a bit below, we have the reactants. Who is the reactant in this case? Reactant dia ialah?
N2NH2.
N2. But N2, we have only 1 as the stoichiometry coefficient. So N2 raised to the power 1. Tak payah tulis pun tak apa. Okay, and then we have hydrogen gas, stoichiometry ratio, we have 3. So it is raised to the power 3. But it will represent by this general formula. CCDDAABB. That is your K expression. Okay, boleh tulis catat dekat sini lah. Ini adalah awak punya K expression. Or the expressions of the equilibrium constant K. Alright. So this equilibrium constant K, kena recognize that equilibrium constant symbol dia K besar, can be expressed in 2 terms. So first one, we have equilibrium constant for concentration, Kc, which is what we done just now, Kc, because you have C, the square bracket represent concentration. And then we have also equilibrium constant for pressure, where we represent by a symbol Kp. So Kc, concentration, Kp, partial pressure. Okay, and then we have a very important point over here. At equilibrium, when you doesn't change your temperature or the temperature remains constant, your K will remain constant as well. Doesn't matter how you change the concentration. What is the concentrations of reactant product? Doesn't matter. As long as temperature does not change, your K do not change as well. So highlight the last point over here, very important. K remain constant if the temperature does not change. Alright, so yeah.
Kalau ada Oh, balance equation juga ke?
Sorry? Kalau ada?
Kalau ada soalan, ada soalan suruh balance equation ke? Kalau ada, dia tulis ke dia punya state dia macam gas ke solid ke?
Ya, chapter ini, hari tu Madu cakap starting from chapter 5, it will be, you need to put in, because starting from chapter 5, you have already learned solid, liquid, gas, right? So this chapter, it is necessary to put the phase. Otherwise, you won't be able to identify who having concentration, who having the pressure. So this one will be covered in a while, yeah? Okay, so this one is just the introduction in theory. So I will further explain to your questions using the examples over here. So ada soalan tak untuk 6.1 tadi? Dia cuma teori sahajalah dekat steps ini. Okay, is anyone having questions for 6.1? No questions? Can I proceed?
Can.
Okay. So 6.2, we were focusing on the equilibrium constant. What is the symbol for equilibrium constant? K. Kc, Kp, depends what you want, concentration or partial pressure. Okay, so let's look at the learning outcome first. First of all, we want to define what is means by homogeneous, heterogeneous equilibria. Equilibria is a plural form of equilibrium. So it's not a typo. Equilibrium means it refers to a plural form of equilibrium. And then write the expressions for equilibrium constant in terms of concentration, which is your Kc, partial pressure, your Kp. For homogeneous and also heterogeneous system, use the equation Kp equals to Kcrt to the power of delta n to solve equilibrium problems. Calculate Kc, Kp, and the quantity of species present at equilibrium. We want to determine the degree of dissociation. We want to predict the directions of the reactions by comparing between the reaction quotient Q and K. So we see how much we can cover for today. But Madam M's, we can cover A, B, C, D for today. Tapi awak kalau tak faham part yang mana satu, boleh tanya, boleh stop Madam. Kalau Madam terlalu cepat ke, let me know. Okay, so first of all, definitions of homogeneous, heterogeneous. So homo, if you know about homophone, homocolor, homotone, that means it's only having one type of a thing, a single substance, a single thing. So when you say it is in homogeneous equilibrium, okay, the words homo refer to both your reactants and products are at the same phase. Kalau homogeneous, semua adalah dalam gas phase. Semua dalam liquid, semua dalam solid, and etc. So only one phase you will see. So it is very important for you to write down the phase in your balance equation. Okay. Then the second one, we have the heterogeneous equilibrium. It refers to reactant and products are all at different phase. Maybe you have one gas, another two will be solid, or you may have one gas, one solid, one liquid, and then another one back to gas. So campur-campur antara tiga-tiga phase ini. Okay, so heterogeneous, it means that all are in different phase. Okay. So boleh tak bagi tahu Madam, tadi nitrogen, hydrogen, ammonia, are they homogeneous or heterogeneous? You're looking at your equation just now.
Homogeneous.
Why is it homo?
Homogeneous.
Why is it homo?
All of them are
Sebab
gases.
state.
Because all of them are gases. Okay, so we back to our equilibrium constant Kc. So Kc again stand for the equilibrium constant for concentration. And I want you to take notes. I really take care on the phases. So concentrations, it only for the aqueous solution and gaseous phase. Aqueous, macam mana kita tahu dia adalah aqueous? Contoh, NaCl solution, it is aqueous. Contoh kalau saya ada apa lagi? Potassium nitrate, for example, it is aqueous solution. Okay, so all the salt that is soluble, we will normally put at aqueous. Siapa yang liquid? Kalau metal melting, molten state of metal, liquid, ataupun H2O hanya yang liquid. Okay, yang lain kalau ada salt solution semua adalah dalam aqueous. Now, AQ stand for aqueous. Okay, so for concentrations, you will only give it to the aqueous species and the gaseous species only. So again, when you talk about concentrations, you're going to use the unit of molar or mole per liter. Or sometimes you're going to see mole per dmq. So this is the unit for concentrations that you have used it before. Okay, so the example just now for Casey, madam have already shown you using the ammonia, yeah? But I want you to look at this red box. There is some correction. Kalau awak nampak grammar, mesti awak correct sendiri, yeah? So over here, I want you to really take notes. I use a different color highlighter. Pure liquid, solid, they have the constant concentration. Constant concentration maksudnya apa? Just now you have already learned constant concentrations, right? Maksudnya apa constant concentration?
Tak berubah.
Tak berubah, do not change, remains unchanged. Okay, so since pure liquid, pure solid, the concentrations is constant. Therefore, whenever you see solid or liquid in your equation or in your balance equation, you just ignore them. Okay, ignore them. You're going to exclude this solid and liquid from your Kc expression. Jangan masukkan dia dalam Kc expression. Okay, contohnya dekat sini. So first of all, if you look at this one, calcium carbonate, calcium oxide, carbon dioxide. Okay, bagi tahu madam dekat sini dia homogeneous ke heterogeneous? What is the
Heterogeneous.
term? Hetero, because you have two type of phases. You have solid and also you have gas phase. Okay, so if you want to write down the Kc expression, first of all, check is this equation balanced. So equation dah balance kan, baru kita keluarkan dia punya Kc expression. Okay, so both your calcium carbonate and also calcium oxide, they are solid. Tengok pada face dekat sini, dia ada solid. Maksudnya concentrations mereka adalah constant. So when it is constant, exclude from your Kc expression. Maksudnya awak tak payah buat macam ni, tak payah show cancel-cancel, tak payah. Teruskan, okay, saya sudah nampak dah solid. So teruskan concentration CO2 and that's it. Very easy, straightforward. Tapi kena pastikanlah awak punya phases adalah betul. So whenever you see S or L, solid liquid, ignore. You just ignore. Okay, so this one is your Kc expressions. Is there any questions related to this one? Kc, yeah? Now we are talking about Kc. Ada soalan? Boleh faham ke? Ting tong, ting tong.
Faham.
Yes, madam.
Boleh, madam.
Kind of kan. So nanti kita cuba lagi untuk confirm kan sama ada awak faham ke tidak. Okay. So again, square bracket represent concentration. Okay. The second equilibrium constant over here we have for pressure. Okay, we have for pressure. So Kp. So pressure, just now madam mentioned, pressure only refer when you have gaseous phase. So for gaseous species only. Okay, so the units over here, we're still using ATM, represent your partial pressure. Okay, so if you look at this KP expression, sama juga produk ke atas, reactant ke bawah. Oh yeah. Okay, so you will see over here on top, over here we have our product C and D using the general formula just now, A, B, C, D. So product on the top, we have pressure for species C to the power of C. Pressure for D to the power of D. Pressure A, the reactant, to the power of A. And then pressure B to the power of B. So ke atas adalah produk, ke bawah adalah awak punya reactant. Okay. Symbol for the pressure, we just stick to the capital letter P. So kalau awak recognize dekat sini bracket dia kita guna bracket biasa sahaja. Sebab kita ada simbol P. So the bracket we using the normal bracket only. Compared to the KC just now, the bracket is square bracket. It has its meaning. So square bracket represent concentration. Okay, so kita guna example yang tadi. Solid memang kita tak ada pressure. So we only focusing the carbon dioxide gas to write your Kp expression. So Kp equals to, okay, product on the top. Tapi reactant dia solid, so kita terus ignore. Ambil hanya carbon dioxide sahaja. So in your normal bracket, we have a capital letter P, and then this pressure refer to the carbon dioxide. So this is your Kp expression. Is everyone good for this?
Yes, madam. Okay.
Alright, boleh faham Kita cuba lagi satu. Okay, question number 1. Write Kc, Kp expressions for the following reaction. But first of all, for A, is it homogeneous or heterogeneous? For A.
Or more.
Or more. Okay. So, kita start dengan Kc dulu lah, concentration. Boleh tak concentration untuk kedua-dua species ini? Untuk kita punya part A. Can we use concentrations for gas species?
Yes.
Yeah. So, siapa duduk ke atas?
NO2.
NO2, your product. And then on the bottom, we have
N2O4.
N2O4, your reactant. Product kat atas, reactant kat bawah. Okay. But you always check lah. Please check the equation. Is it balanced or not? So, in this case, Madam dah bagi yang balance dah. Okay. So, kita buat lah. Okay. Product ke atas. So, square bracket. Inside, we have NO2. Any power?
2.
To the
Two.
power of 2 because you have your coefficient 2. Raised to the power of 2. Kalau dia 3, raised to the power of 3. And etc. Okay, at the bottom?
N2O4. No power.
N2O4, very good. So this is your Kc expression. Okay, try also for Kp. Okay, equilibrium constant for our partial pressure. So partial pressure, because both of these species are gases, so we still can write the symbol for reactant and product. So kita try ya, you buat sama-sama. Jangan tunggu jawapan madam ataupun madam bagi masa dulu. You try to write out write out somewhere in your paper, write out in down below the questions here. Okay. Apa yang saya kena tulis kat atas?
Product.
Product. Using symbol
P.
P. Okay, so pressure for the product NO2, we're using the normal bracket and still the same coefficients raised to the power 2. Do you get this one?
Yes.
Yes,
Okay,
madam.
and the product and the reactants, we have pressure of N2O4. So here we go, Kp expression. Okay, the second one for part B. Heterogeneous or homogeneous?
Hetero.
Hetero.
Hetero. Apa yang kita kena ignore?
Solid.
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 Kenapa kita ignore solid?
Constant concentration.
Constant concentration.
Madam nak tanya sikit constant concentration, dia ada tak concentration?
Ada.
Ada.
Ada ke tak ada?
Ada.
Ada. Cuma dia constant. Okay, ada concentration ya, bukan tak ada. Dia ada concentrations tapi dia constant. Okay, so we start with the KC expressions for part B. We only focusing on the gaseous species. Or if you got aqueous, we'll focus on aqueous also lah for concentration. Okay, so on top over here, we have our bromine gas. So what is the power?
Berapa tu?
Half. So straight away, half the coefficients we raise to the power of half. And then Kp as well refer to only the gases. So using the symbol P, capital letter P, bromine gas raised to the power of half. So quite straightforward lah. So is there any questions over this part? Ada soalan nak tanya?
Tak ada, Madam.
Ada.
Boleh ikut ya. Okay, sekejap ya, Madam check. I think that's all for this page. And we go to our next page. In your notes, there is some blank space for you to write in. Okay, so derivations of formula. Okay, we refer to this formula. Kp equals to KCRT delta N. Formula ni memang fix, tapi awak kena belajar macam mana nak buat derivation. Okay. It will be slightly complicated if we're using a general equation. So we will derive one time using the general one, and then we were using a specific equation to derive the formula in the next example. Okay, so we start off with Kp, Kc expression. Kalau Madam terlalu cepat bagi tahu Okay, so here you go. Kp, we have the expression P, pressure for C to the power of C and etc. Then Kc expression over here, Cc, Dd, Aa, Bb. And over here, if you still recognize in chapter 5, we learned about the ideal gas equations, PV and RT. Okay, why Madam start with Kp first? If you're looking at this equation, Kp is the subject. So we want to keep Kp as the subject. So we begin with Kp first. Okay, so in this case, if you can see over here, we have Pc, Pd, Pa, Pb. So I want you to use PV and RT to make this PC, PD, PA, PB as your subject. Contoh dia macam ni. Okay, so pressure of C. So let's begin with PC, yeah? Okay, when we try to rearrange this PV and RT, so number of mole for C, RT over the volume. So using PV and RT for each of your gaseous species over here. Okay, and then if you recognize over here, concentrations equals to number of mole over volume. So N over V give you the concentration, C, RT. But of course, in this Kc expression, we are using the square bracket as the symbol. Then we just change it a little bit. So concentrations of C, RT. So dapatlah dia punya PC as a subject in terms of the concentration C. Okay, sampai sini boleh ikut? Can you follow? Boleh. Okay, Mary tunjuk satu contoh lagi lah untuk PD. Sama juga number of mole of DRT over the volume. So we have the concentrations of DRT So using the symbol of the square bracket, so PD equals to concentrations of DRT. So sama juga lah kita boleh apply pressure untuk gaseous A. So concentrations of A, RT, partial pressure for species B equals to concentrations of B, RT. Okay, sampai sini boleh ikut?
Boleh, madam.
Boleh, madam.
Okay, so now we want to try to substitute this PA, PB, PC, PD back into the one that madam circle over here. So we try substitute inside the bracket. So up on the top, we have concentrations of CRT raised to the power of C. Okay, so sama juga lah untuk yang lain, concentrations of D, RT to the power of D. And then down there below, we have concentrations of A, RT to the power of A, B, RT to the power of B. Okay, so we want to extract the concentration. If you look at this KC expression, kita nak cuba untuk keluarkan benda ni. Sebab kita nak substitutekan KC. We want to extract the CCDD AABB from this KP expression. So we try over here. Nah, awak salin dulu. Kalau takut cepat sangat, awak tak boleh ikut. Dah sampai sini bagi tahu madam Make sure you follow this one. Don't screenshot only. Ikut sama-sama. Kalau screenshot awak tak nampak macam mana nak buat substitution.
Ya, madam.
Nah, yeah. Okay. Everyone, the rest of you?
Dah, madam.
Ya, madam.
Okay. So now we try to open up the bracket. Concentrations of C raised to the power of C because they are all in the bracket. So C to the power of C. Then we have RT also raised to the power of C. Dia bukan raise power sekali saja untuk setiap species dalam awak punya bracket. So C to the power of C, R to the power of C, T to the power of C. Lepas tu kita ada juga dekat sini concentration D raised to the power of D. And then RT inside the bracket still D. Down below also the same. And then concentration A, power A, RT in the bracket A, B to the power B, and then RT to the power B. Okay, so I'm using a different highlighter and then highlight the things that for you to see. What do you see? Is it the same as the KC expression?
Same.
Same. So we do the substitution. So we just try to simplify it. So equals to KC. So over here, RT, 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 they are all the same. So if you learn your mathematics, you know that C and D, if we times the power, it is what is the addition? So C plus D. Okay, and then we will minus, because divisions, right? The power divisions is minus A plus B. So over here, A plus B. So you need to take notes. This delta N, okay, refers to the number of mole or the stoichiometry of your product, okay, minus reactant. Okay, stoichiometry, coefficients of product minus reactant. So for the products over here, we have C and D. So C plus D, both are your product, minus the reactant A and B. So it will give you the symbol delta N. So we will conclude over here, Kp equals to Kc, RT delta N. This is the formula that we want to get from the general formula up there.
Madam,
Yes.
PB
Atika kenapa? Sorry.
macam mana dapat PA dan PB? Saya cuma keliru yang tu je.
PA, PB ni
Ha.
sama juga macam atas. Sekejap ya, maintain tukar satu warna. Okey, dia sama juga macam tadi. Kalau kita nak carikan PA, so we try to rearrange back your PV and RT over V. So N dengan V, dia adalah concentration kan. So MART. So kita cuma tukar dia punya simbol daripada N bagi square bracket saja. Biasanya kita guna capital letter M as a symbol, right? But in this case, because we want to express the KC expression, we're using the square bracket RT.
Okay, Madam, faham.
Okay, sama jugalah untuk PB. So PA, PB, PC, PD, they are all similar. Okay, is everyone good? Any questions you would like to ask? Ada soalan? Dapat ikut? Am I too fast?
Boleh,
Am I too
madam.
slow?
No. Okey je.
No, okay je. Okay, you cakap okay, so you buat sendiri. Tak adalah, sekejap Alright, so let's just try the first questions here. In your notes, Matter only give you questions. It will be good if you take out a new piece of paper and then write over there. Sebab Matter hari tu tengok awak punya palette, ramai yang buat terus dalam nota tapi tempat tak cukup. Lepas tu awak squish inside the notes with a very small space. Macam mana awak nak revise nanti? So the walking style is quite long. So please take out a piece of paper and then write on top of that. This one is 6.2. Okay, question number 1. So you write down your answer over there. And then later on, you can stapler it together with the notes. Easier for you to do revision. Okay, kita try soalan pertama ini. And then we will take a 5-minute breaks. And then after that, we will continue question 2 and 3 and so on. Okay, so kita try So for the following reactions achieve equilibrium when the partial pressure of bromine gas is 0.60 atm. So units refer to the pressure. So again, in this species, which one we are going to ignore?
The solid.
Solid. Dia tak ada pressure, concentration dia pun constant. So Kc, Kp expressions, both we are going to exclude the solid phase. So for your part A over here, based on the reactions above, we want to derive the equation just now. Remember just now we are using what we are using? We're using the general formula, but now we want to using a specific chemical equation. Okay, come up with your Kp expression. Tak pernah buat sekali kan? Bagi tahu madam Kp expression dia macam mana?
P PR
Mm-hmm.
2 to the power of 1/2.
Yes, exactly. How about Kc?
BR2 to the power of 1/2.
Tadi kita sudah buat sekali kan? Okay, so remember that we want to keep your Kp as the subject and don't forget about your PV and RT as it related to the pressure. Okay, so we're starting from PV and RT. Because why? We want to substitute your PBR. Okay, so we want to write the partial pressure of BR2. So we try to rearrange a little bit. Number of mole of bromine, RT, and then volume. So N over V give you the concentration. And then we try to convert into the square bracket. Not convert lah because they are the same thing. Cuma tukar simbol sahaja. Okay, RT. So now you see we have the PBr2 equals to concentrations bromine, RT. And we are going to substitute inside the brackets over here. Okay, Madam buatkan nombor untuk awak ikut 1, 2, 3. Lepas tu yang keempat kita buat substitution. Okay, substitute yang keempat dalam awak punya PBR2. So now we substitute inside PBR2 the concentration RT raised to the power of half. And what is your next step? Next kita nak buat apa? Dah sampai sini dah. Apa yang kita kena buat?
Pecahkan dia ke?
Pecahkan dia. Macam mana pecah? Guna pisau, guna
BR2
BR2
to the power of 1 over
Power of
2.
1.
RT
yeah, BR concentration half and then RT to the power of half. And then you can see over here, this is actually your Kc expression. So kita buat substitution lah Kc. Okay, and then RT. How am I going to find this delta N? Why I got 1 over 2. So how am I going to write this one? Macam mana nak cari delta N? Delta N equals to
1 minus 0.5.
coefficients of the product minus coefficients of the reactant. But since you have FeBr3 solid and then FeBr3 solid. I think over here salah ini FeBr2. But no worries lah, dia tak akan ganggu soalan. Okay. So delta N product minus reactant. So we only got the coefficients for the gaseous species. So half minus half, minus 0. So delta N equals to 1 over 2. And therefore, you have successfully derived the equation, the formula. So, cara ini adalah untuk equation yang specific. You can use to any of your balance equation. Okay, any of the balance equation. Kalau yang general, guna yang tadilah ABCD. Yang specific, depends kepada equation. Okay, so any questions until this part?
No, madam.
No, madam. Okay, kalau tak ada, kita try. Determine Kp, Kc. So, what is the value of your Kp? What is the value of your Kc? Okay, Kp kita akan guna tadi formula, expression untuk Kp lah. Kat mana nak carikan pressure untuk bromine gas? Where do you find the pressure of the bromine gas?
Dia dah bagi kan?
Malam.
Oh, dia dah bagi pandai. 0.608 atm. So, kira lah. To the power of half and what is your value? And then, because this question doesn't give us any concentration, so fikirkan macam mana kita nak dapatkan Kc. Bagi madam value ni dulu. Kp value apa dia?
0.7746.
Very good. 0.7746. Okay. Everyone get it?
Dapat.
Dapat. Yay. Okay. Macam mana nak dapat Kc? Tak ada concentration pun, madam. Concentration biar tu tak ada. Kita nak cari Kc macam mana? Ting tong. Anyone?
Masuk dalam equation.
Pakai formula. Dah bagi formula. Kp kita value dah ada. Gas constant R memang dia ada value. How about T?
The temperature.
Oh, tak ada T. Madam, tak ada T.
Normal.
Normal. Normal berapa? 30.
20.
22.4.
Normal
25.
temperature 25. Your room temperature and pressure, yeah, 25 degrees Celsius, which is also equal to 298.15 Kelvin. So kira kan apa awak punya value
Oh,
KC?
madam.
Yeah.
Madam.
Yeah.
So if the temperature is not mentioned,
Mm-hmm.
so it will be it will use room temperature.
Yes. Tapi bukan room temperature Malaysia, ya?
Huh? In accordance to place
No lah, the standard one lah, 25.
Oh, alright.
So kira kan, bagi madam jawapan KC. So you're using your KP value just now as 0.7746, and then you have your value of gas constant R. Siapa ingat lagi gas constant R value dia apa?
0.08206.
Very good, well done. So remember, temperature must convert into Kelvin sebab kita pakai gas constant R. Dalam gas constant R, unit dia ATM. Meda lupa. Liter lagi. Unit dia ATM,
Per
liter per mol per
Kelvin.
Kelvin. Oh, Meda lupa nak bagi tahu. Ini tak ada unit No unit for equilibrium constant. Boleh catat no unit. So memang sini memang tak ada unit lah. KC pun tak ada.
Madam, dalam equation KP tu why triangle N tu tak letak je 1/2?
Oh, in your question 1/2.
Sorry?
In your question 1/2, ya.
Oh, tak ada.
Tak apa, tak kisah pun. Dia punya cara jawab dia sama. Kalau dia sudah bagi 1/2, then that means your duration stop until this part. Kalau dia bagi delta N, you stop until this part. Tak sama je dia punya value delta N.
Okay, madam.
Alright. Anyone got the values, KC? Ding dong.
0.1566.
Yes, very good. 0.1566. Okay, just simple calculations of it over here lah. So KP 0.7746, KC 0.1566. Again, same thing, no unit. Tak payah tulis lah, awak cuma catat untuk alertkan sendiri saja. K tak ada unit. Okay, so any question under this part before we take a 5-minute break?
Oh.
No, Irfan, at last I see your voice. Irfan banyak kerja tak hantar ya? Lepas tu diam dah. Okay, so no questions, huh?
No, madam.
Okay, if no questions, then we take a 5-minute break. Now is 9:05. Come back at 9:12. 9:12, yeah? All right.
Kind of love is getting harder to find. I'm loving the way your body speaks, but something's telling me I'm losing my spot, and I don't mind chasing the right creep. I just got shit I'm doing today. The way you look at me, I'll never plan to give you all of my time. Baby, I'm so sick of dreaming of you. I can't eat, can't sleep, can't drink without you. You're the pebble that's been stuck in my shoe. I asked the internet to tell me what to do, and I don't want chasing how you create. I just got shit I'm doing today. Can I switch off what you're doing to me? No. I'm loving the way you look at me. This kind of love is getting harder to find. I'm loving the way your something's telling me I'm losing my spot. And I don't mind chasing the high creep. I just got shit I'm doing today. The way you look at me, I'll never plan to give you all of my time. I'm so obsessed what you're doing tonight. I got no plans, is it cool to stop by? I'll fly, even if you're on the ocean's other side. You know I'll go, I'm catching that flight. I don't mind how you create. Still got shit I'm doing today. I can't switch off what you're doing today. No, no, no. I know that we're alright. It's in your eyes. So don't you stop me, cause I'm loving the way you look at me. This kind of love is getting harder to find. I'm loving the way your body speaks. But something's telling me I'm losing my spot. And I don't mind chasing the high queen. I just got shit I'm doing today. The way you look at me, I'll never plan to give you all of my time. I know that we're alright. It's in your eyes. So don't you stop me, cause I'm loving the way you look at me. This kind of love is getting harder to find. I'm loving the way your body speaks. But something's telling me I'm losing my spot. And I don't mind chasing the high queen. I just got shit I'm doing today. The way you look at me, I'll never plan to give you all of my time. We're looking at the sun, I'll spend the night with you. And I
All right, class. Are you back? Is everyone back already?
Yes, madam.
Tak ada suara. Tak ada suara. Dengar suara. Dengar ya?
Benar, madam.
Okay, so we want to continue our second questions. All right. Yeah, can you see my screenshot? Nampak soalan, madam?
Nampak, madam.
Nampak, madam.
Okay, so let's just look at the question first, huh? And then we interpret and see what is the questions asking. So first of all, equilibrium concentration. Yang ini perkataan penting. Madam highlight sebab dia bagi tahu concentrations at equilibrium. Okay, so equilibrium concentrations for reactions between your carbon monoxide, CO, and the molecular chlorine, Cl2, to form COCl2 gas at 74 degrees Celsius. So the concentrations given, concentrations of CO, Cl2, CO, Cl2 0.14. Okay, so the question's asking for the equilibrium constant Kc and Kp. So rasanya apa yang kita boleh kira dulu? Kc ke Kp?
AC.
Kc, because concentration is given. But of course, in order to calculate for Kc, you need to get this Kc expression. Tapi madam, macam mana nak dapat Kc expression? So how is it? What should we do? To get your Kc expression, what is the first step that you need to do?
Buat equation.
Equation. So you have got your carbon monoxide, which is a gas. And then we have the chlorine, also gas. For your informations, if you got fluorine, that will be in gas. If you get Cl2, if it doesn't mention, this is the standard state that you have got for group 17. Chlorine also gas. Bromine normally will be in liquid, but if mentioned, gas also can. Okay, so either one. And then last one, iodine, the standard state, it will be in solid. Okay, so this one, if it doesn't mention Cl2 is a gas. So to form, this is an equilibrium system. Remember your arrow. Madam faham setiap kali sebab awak sudah biasa guna arrow yang single direction. So you need to keep on practicing this reversible arrow. Okay, so to produce your CO, Cl2 gas. So is this equations balanced?
Yes.
Balance.
Yes. So kalau sudah, baru kita proceed kepada KC expression. So product on the top, reactant on the bottom. So it's quite straightforward, you see, once you know how to come up with the KC expression. So soalan ini akan jadi agak senang sikit. So product on the top, reactant on the bottom. So Cl2. And then because all of them are in stoichiometry ratio 1, so you don't have any power, and you just need to fill in your values. So take notes, tadi dekat KC expression, madam pakai square bracket. But when you want to insert the value, we will convert it to normal bracket. Maksud madam dekat sini, 0.14, guna bracket biasa. So if you want to use bracket lah, if you don't want, doesn't matter. And then 0.012 and 0.054 for the chlorine. So calculate for your values. Okay, is anyone getting the values of KC?
216.049.
Sama.
0.49. Okay, very good. So 216.05, yeah? Is there any unit?
No.
No unit.
No unit. Well done. Okay, so KP, how do you calculate thing for KP?
Equation.
Equation. Okay, so equation tadi masih ingat lagi tak? KP sama dengan ini kena hafal tau. KP sama dengan
KC bracket RT to the power of
delta N.
delta
Okay, how about your value of delta N? Kita check. Macam mana nak dapat value delta N? How do you get delta N? Any idea?
Product minus reactant.
Product minus reactant. Product, we have 1. Reactants over here, we have 2. So 1 minus 2 give you negative 1. Sebab semua adalah dalam gaseous phase. It is a homogeneous equilibrium system, ya. Okay. Kenapa dapat 2? Sebab satu-satu lah. Reactant dekat part reactant ada 1 mol. So ratio dia adalah 2. Okay, so I give you the value and then you can check it in your own pace. So value dia 7.58. Catat dulu. Catat dulu. Nak kira kemudian boleh. Okay, 7.58. Okay, catat. Dah catat? Sebab ini quite straightforward lah. So, madam bagi jawapan awak untuk buat exercise sendiri. Boleh ke?
Boleh.
So the temperature would be as always room temperature unless stated.
Hazim tengok soalan.
Okay. Sorry.
So unless soalan dia tak bagi. Kalau soalan bagi, kita ikut. So temperature kita ambil terus ke kena buat sesuatu?
Tukar kepada Kelvin.
Need to convert to Kelvin.
Ya, tukar Kelvin ya. Okay. Right. Okay. So for question number 3, Madam will give you the answer as bukan bagi answer. Sekejap Okay. Madam bagi interpret soalan, bagi jawapan, nanti awak kira sendiri ya. Ataupun sesiapa yang sempat bolehlah kirakan. Okay, so question number 3 over here, it tell you that equilibrium constant Kp for the reaction is 158. Okay, soalan macam ini awak kena baca satu persatu. Jangan skip terus. Madam, mana dia bagi Kp, mana dia bagi Kc. Dia hiding dekat sini. 158 is the equilibrium constant Kp. So the questions also say that at equilibrium, ayat ini sangat penting at equilibrium. The partial pressure of NO2 0.400 atm, NO 0.270 atm. So maksudnya value ini adalah partial pressure pada equilibrium. Bila dia sudah capai equilibrium, ini adalah partial pressure untuk NO2 and O. Okay. And then the question asks, what is the equilibrium partial pressure of oxygen? Okay, so in this case, equations have already given. You have already balanced. So what you need to do is to come up with your Kp expression, substitute the value to find the partial pressure of oxygen at equilibrium. Okay, Madam nak awak highlightkan perkataan equilibrium. Nah, dekat sini apa yang Amanda highlightkan? Equilibrium. Kena highlightkan. Okay. So, Amanda check dulu awak punya Kp expression. What will be your Kp expression? Product over reactants, and you will get expression dia macam mana?
PNO to the power of 2, PO2 over
PNO bracket. Very good. So we have partial pressure of NO raised to the power 2, and then oxygen, because coefficient is 1, so pressure oxygen raised to the power 1, you don't have to write. And then partial pressure of your reactant NO2 raised to the power of 2 as well. Okay, make sure you have the symbol P, because now you are writing for the partial pressure. Jangan terus bracket NO sahaja, bukan mesti kena ada symbol P. Okay, and then you do your substitution, and I will give you the answer for you to check. So partial pressure of oxygen at equilibrium 346.78 atm. Yang ni catat kita sendiri. Sebab dia agak straightforward lah, cuma buat substitution saja. Okay, dan copying? Dah catat?
Madam, so the Kp will be 158
Yes.
as aforementioned before, right?
Yes. Soalan dah bagi dah 158. Alright, so catat jawapan, nanti awak check sendiri. Ada masalah boleh bagi tahu madam lah. Okay, so exercise yang madam nak awak buat, hari tu dah bagi tahu kan, hari ni tak ada exclusion kena buat juga. Okay, so madam pilih soalan 3 dengan 4. Okay, into your Google Classroom. So GC, the date for today is 26. So question number 3, question number 4. Take note on the phases. Okay, lepas tu madam nak proceed kepada example yang seterusnya. Yang tadi simple kan soalan dia. Okay, now we increase the difficulty a little bit. Dah catat ke? 3, 4 GC? Okay. Right. The reason why madam asked you to highlight or underline the words equilibrium. Now here you go. We want to introduce you the ICE table. Okay, ICE table, yeah. So let's look at this this chart lah, this short notes. The problem related to your equilibrium constant, normally we have two types. The questions might give you the equilibrium quantity. Quantity refer to concentration or partial pressure, like just now what we done. Soalan bagi concentration at equilibrium. Soalan bagi partial pressure at equilibrium. And you are requested to calculate the value for Kc, Kp. So this one is straightforward. Straight away the equation or the questions is already at equilibrium. So equilibrium quantity kirakan untuk Kc ataupun Kp. Okay. But now, what if the questions doesn't give you the concentration or the partial pressure at equilibrium, but it gives you initial quantity? That means it gives you initial concentration, nothing happened yet. The reaction doesn't happen yet. Or they give you the initial partial pressure. Okay. And then give you the value of Kc, Kp. So we need to do something in order to get the value of your concentration or partial pressure at equilibrium. Sebab kenapa Madam suruh awak highlightkan perkataan equilibrium tadi. Okay, so solve the equilibrium quantity. So at this time, when the questions give you your initial quantity, we need to use the ICE table, or we call it as a reaction table. But Madam prefer ICE table lah because it stands for ICE, initial change in quantity, and then E stands for equilibrium. So maybe you refer to initial concentration, change in concentration, equilibrium concentration. So maka awak punya ICE table kita akan pakai concentration. Okay. Or if the questions give you partial pressure, then you will use initial partial pressure, change in partial pressure, or equilibrium partial pressure. So ICE table refer to the partial pressure. Okay. So ada dua senario kan? Kita tengok soalan yang pertama dekat sini, dia senario yang mana satu? So now you have already know they have two meanings, right? So let's look at, we interpret the question first. Okay, you tell me which scenario is this. So let's say we have this one as our first scenario, this one is our second. Tell me about question 1 at below here. Is it scenario 1 or scenario 2?
One.
Why is it 1? Awak nak cuba ya?
Sudah bagi concentration kan?
Tapi concentration dia initial ke, dia equilibrium ke, macam mana nak tahu?
Equilibrium.
Kenapa?
The
Which one is the
equilibrium-
keywords? Mana satu keywords dia? Apa dia?
Equilibrium mixture.
Yeah, so you see, equilibrium was established. A small sample of equilibrium mixture extracted. So it was found to contain this much of your reactant, your product. So dekat sini, maksudnya dia adalah senario yang pertama. Concentration yang dia bagi memang dah ada pada equilibrium. So this one is similar like our question number 1, 2, 3 just now. You come up with the Kc expression, you substitute the value, and then you calculate for the value Kc. Do you get me?
Yeah.
Seorang saja yang get. Lain?
Yes.
Yes.
Madam.
Boleh ya? Okay, so Madam bagi our value Kc dekat sini. Value dia 9.8. Catat, nanti awak kira sendiri. Sebab dia straightforward. Keluarkan Kc expression, substitute, kira. Okay, so we proceed to the scenario 2.
Madam,
Yes.
where did the 9.8 came from?
Awak kena kira lah. Madam bagi jawapan, awak kira sendiri. Ini jawapan. This one is your answer. This one is the answer. Hazim kena kira sendiri. Is that okay, Hazim?
Okay, madam.
Okay. So Madam want to introduce you the ICE table, how we are going to use, when we are going to use, how you are going to interpret the questions. So proceed to question number 2. Okay. Tell me the keywords which indicate this one is the second scenario.
Initial concentration.
Initial
Very
concentration.
So the question says, suppose that a flask containing H2I2 has been heated to 4 to 5 degrees Celsius, and you have the initial concentration, which is 0.0157 mole per liter. Okay, so initial concentration adalah untuk H2I2. And you are given also another thing. At equilibrium, the concentrations of HI is equals to this value. So diberi dua concentration. Okay, initial concentrations for the reactant, and then at equilibrium you have the concentrations of HI. Okay, so using this experimental informations, calculate the equilibrium constant. So I want to know, based on this information, is this equilibrium constant refer to Kc or Kp? Dia tak bagi tahu dia nak Kc ataupun Kp. Apa kata awak? So what do you say? Is it Kc or Kp?
KC.
Kc. Sebab soalan bagi concentration, ya. Okay. So in your ice table, you can draw your own table. Yang ini madam dah already write it. So I will have your initial concentration. So kalau awak nak tulis perkataan initial concentration, can, no problem. Or you may write the symbol initial concentration. So symbol square bracket represent concentration, and then I'm using the abbreviation I to indicate initial. So I have my unit mole per liter. Okay, and then I have to change in concentration. Remember ICE. The second column over here means change of concentration. Again, I'm using the unit mole per liter. So ikutlah soalan kalau bagi capital letter M, I will tulis capital letter M. And then at equilibrium, concentration at equilibrium. Okay, so now another 3 columns over here, you need to put the equation on the very first row. Okay, so over here I put it hydrogen gas plus my iodine gas in equilibrium to produce 2 mole of HI gas. Okay, always make sure that this equation is balanced. Kalau soalan dia tak balance, awak balancekan sendiri. So always make sure this equation is balanced. So now we fill in the detail inside the table. So we have the initial concentrations of H2, I2, which is this value. So kita isi dulu. Initial, before anything started. So we have 0.0175. You don't have to write units again sebab dekat sini sudah ada. Okay. Iodine pun sama jugalah 0.0175. Anything for HI initially?
No.
No, nothing. So we put 0. Okay. So we have initially H2I2 and then no concentrations for HI. So pay attention to the second column over here. Madam highlight kan eh? Okay. So when Madam say you need to have a balanced equation because it is important for this column, change in concentration. So if let's say over here, hydrogen, we have only 1 mole. So reactant will decrease over time. So in this case, we will minus certain amount of the concentration. So minus X. Kenapa minus 1X saja? Sebab coefficient dia 1. So kita tolak 1X. So dia ada dia punya reason. Negative sign represent that reactant will react. So you're going to decrease this amount of reactant. Okay. How about for iodine? How many you're going to subtract? Minus how many X?
1.
1X as well because the coefficient is 1. Okay. So now, initially we doesn't have any product HI. So after certain time, the change in the concentration, they will increase in the concentration. So kita akan tambah, okay, concentration untuk HI. But how many am I going to add?
2x.
2x.
2x. So very important that you recognize that equation must be balanced. So for reactant, minus X for hydrogen and also iodine gas. And then for reactant, because the coefficient is 2, so we need to add 2X in this case. Kalau dia 3, awak tambah 3X. Kalau 5, awak tambah 5X. Depends lah whether it is reactant or product. Can you follow?
Can.
Okay, so untuk equilibrium kita cuma tambahkan saja 0.0175 minus X, 0.0175 minus X, and then 2X over here. Okay, but there will be one question. Madam, how am I going to know what is the value of X? So now, come back to the questions. You always refer to the questions to get any clue. The clue is always in the questions. Okay, so it says that at equilibrium, concentrations of HI equals to 0.0276. So maksudnya dekat equilibrium, kita punya concentration HI, okay, sama dengan 0.0276 mol per liter, which also means this value will equals to 0.0276. So we do some calculation. 2x equals to this value, and then you will get the value for your x. Okay, you don't have to worry about the 2. This 2 is to use to identify how many concentrations changes. Okay, dia tak akan effect dekat concentration yang dia bagi dalam HI dekat sini. So HI memang dia satu dekat sini saja, 0.0276. Tak payah tambah 2 dekat sini ke, nak dapat 2 ke, divide 2 ke, tak payah. So memang 2x ini sama dengan concentration yang dia bagi. Do you get me? Teng.
Yes, madam.
Okay, kalau awak takut awak confused kan, okay, so if you hide everything, mana tak dapat nak tutup, awak hanya fokus pada column E dekat sini. Okay, so let's say at equilibrium, the concentrations of HI, according to the questions, equals to 0.0276. So maka awak akan nampak 2x dia adalah sama dengan value ini. Nah, so carilah untuk x, which is equals to 0. What's the value of x?
0.0138.
Okay, so Madam highlight kan untuk highlight pula warna salah jap. Okay, so I use green color over here lah to indicate equilibrium HI. Okay, so 0.0138. So now the questions asking for Kc. Before we want to calculate anything, kejap ya. So now you got the value of X. Sebenarnya awak boleh terus kira concentration H2I2 over this part. So 0.0175 minus 0.0138. Boleh kira terus equilibrium concentrations for H2, equilibrium concentrations of I2, and then equilibrium concentration for HI, you have already got it. Boleh terus kira lah. Okay, can let me know what is your answer lah. 0.0175. What's the value that you get?
Uh, 3.7 times 10 to the power of negative 3.
Yang lain dapat sama?
Yes, madam.
Yes, madam.
Okay, so now to calculate for Kc, you have already got your equilibrium concentration, and then come up with your Kc expression, and then calculate for the value. Okey, Mada bagi jawapan dekat sini, bagi tahu sama ada awak dapat jawapan ke tidak ya. 55.64. Mada bagi masa sikit, kirakan. So yang penting equilibrium concentration lah kalau nak kirakan Kc.
Dapat.
Dapat. Ada soalan tak kalau untuk soalan guna ice table? This one is first time you using ice table ya.
Madam,
Mhm.
so the initial concentration for HI is 0, right? Or we don't know?
It's 0 because it gives the initial concentration only for H2 and I2. If let's say they also give you initial for HI, there will be another case that we will learn a little bit later lah at the end of 6.2. Maybe next hour.
Okay.
There will be
Alright.
some scenario where you have all of the initial concentration, reactant product semua ada. Okay, there will be another case. So we learn it bit by bit. We're starting for this one first. Okay, cuba keluarkan KC expression dapat tak?
Teacher,
Mhm.
dekat soalan dia tulis at equilibrium HI equal to 0.0276 kan.
Mhm.
Tapi HI tu bukan untuk 1 mole of HI ke? Kalau yang bawah tu bukan dia dah 2 mole of HI. Jadi dia punya nilai
Okay, itu
final
yang Madam mention tadi. Yang kalau awak tengok dekat equation Madam padam semula sebab tu Madam takut awak confused. That's why Madam highlight kan. So let's just begin again. We start one again over this part. So Ilfan and the rest of it, if you confused about this part, focus back again over here. Okay, so dia punya equation memang dia bagi balance 2 mole of HI. But that 2, this value of 2 refer to the stoichiometry ratio. Okay, this stoichiometry ratio is to indicate how much it will change. Sebab dekat kolom yang kedua, dia punya row yang nombor 2 ni, dia adalah change untuk concentration. So kita tengok pada ratio 2 ini untuk tengok berapa banyak concentration dia akan tolak ataupun tambah. Dia punya kegunaan dekat sini. Okay, so 2 mole of HI will add or will increase by 2 times. So we add 2x over here. Okay, tapi kalau awak ikut ayat dekat sini, ayat yang Madam bulatkan Okay, at equilibrium concentration HI equals to this value. So kalau awak tengok pada kolom yang ketiga untuk E, kolom concentration equilibrium, kita Madam bulatkan kotak ini. So, dengar baik-baik Concentrations of HI at equilibrium equals to 0.0276. Maksudnya, kita tak tengok pun dia punya number of mole. Mole dekat depan sini untuk tengok berapa dia tukar X dia. Value X dia nak tambah 2 ke, nak tambah 3 ke, dan lain-lain. So value 0.0276 tu memang untuk concentration HI. Tak payah divide, tak payah darab. Boleh faham?
Okay, boleh.
That's why it's important for you to draw this ice table so you can see, okay, which column I need to put the values in. So kalau saya sudah letak 0.0276, maksudnya tadi kalau saya kira lah, okay, 0 tambah dengan 2x. So 0 plus 2x equals to the values given. So keluarlah dekat sini. 2x equals to 0.076. Okay, so don't confuse. Whatever their value they're given is given and is say already at equilibrium, we take the whole values in. The ratio only to indicate the changes. Ataupun dia nak bila awak nak keluarkan KC expression, stoichiometry ratio tu dia akan jadi power. Dua perkara tu saja untuk dia bina balance equation. Stoichiometry coefficient. Okay, tak apa yang ni awak kena praktis banyak untuk nampak macam mana kita nak carikan awak punya jawapan. Okay, so the rest of you, do you get this value of KC? 55.64.
Yes, madam.
Got it, yeah?
Take me I'm going up to be honest. Take me a while to understand the whole jalan kerja.
Yeah, but
But now I understand it.
yes. So we always start from the easiest and then we slowly proceed to the harder one. But this one is still considered quite easy, yeah? Okay, so 55.64. Okay, we try one more questions for you. Okay, oh no. Okay, try one more questions, but madam not sure whether I'm enough time or not. So maybe I will stop halfway. Tapi madam nak bagi tahulah cara untuk awak buat dekat sini. Okay, so question number 3, you ready?
Yes.
Yes, ikut. Kalau madam terlalu cepat kena bagi tahu. If you didn't say anything, I will just proceed. Okay, so in these questions, it say that calculate the equilibrium. Oh, terus bagi soalan dah. Calculate the equilibrium concentrations for all species if you got 3 mole of H2, 6 mole of F2 are placed in 3 liter of container. So Kc value also given. Equations given, Kc value given. So if you can't understand the sentence, always draw a diagram. So let's say this is my 3 liter container. So I put in 3 mole of H2. I put in 6 mole of F2. So is it this, at this point, when I put in H2, F2, is it initial or equilibrium? Soalan tak ada bagi langsung
Initial.
kan? Initial. So awak kena nampak macam mana reaction ni berlaku. So dia letak H2, dia letak F2. So this one is your initial concentrations, whereby you can calculate concentration equals to number of mole over volume in liter. So ini boleh kira sendiri. Okay, so kita kira dulu. Initial concentrations of H2 sebab dia bagi number of mole. Jangan lupa unstable. Setakat ini kita pakai concentration. Okay, so H2 initial concentration 3 mole over 3 liter, which give you 1 molar. How about fluorine? Berapa molar ada?
2.
2 molar. Okay, so because you have 6 mole of fluorine, you have 3 liter. The volume is the same. So 2.0 molar. Okay, so in your ice table, you're going to use partial pressure of concentration. What am I going to fill in as the subject?
Concentration.
Concentration. Ifan baru bangun ke?
Tak.
Okay, so initial concentration, yeah, using the symbol or using the sentence. Change in concentration, unit. And then equilibrium concentration, unit. Okay, and then I fill in my equation. So hydrogen, gas, fluorine, gas, in equilibrium to produce 2 HF. Nampak macam lebih kurang sama je. Okay, tak apa, kita try. Okay, so the target we want to find is to find the concentration. Kita highlightkan target. This is my target. I want to find concentration, concentration, concentration. Okay, but don't worry, I fill in the table first. initially I have 1 molar of hydrogen gas. I have 2 molar of fluorine. How about HF?
0.
0. What is the changes for HS? H2? Minus?
Negative X. Minus
Minus
X.
X.
Minus X. Sebab dia ratio 1. How about F2?
Sama.
Sama. HF?
Minus A plus 2X.
Positive 2X. Sebab initially don't have anything. So, of course, it will increase when the reactions happen. Okay, so now in the equilibrium, we have 1.0 minus X, 2.0 minus X, and then 2X. But now, I don't have any clue of the value of my X. Okay, in terms of concentration lah, dia tak ada bagi pun concentration untuk mana-mana satu species dekat equilibrium. Okay, which means I have to utilize the value of my Kc to identify the value of X before I'm able to calculate the equilibrium concentration. Okay, tak ada masalah. Kita tengok dulu Kc expression dia macam mana. Let me know about the Kc expression. Do you have anything after this?
No.
Okay, Madam agak anjak sikit masa kita try habiskan soalan ni. So, you bagi respon cepat sikit, Madam, cepat habis.
HF.
HF to the power of?
2.
2. Bawah kita ada?
H2.
H2, F2, both to the power of 1. Okay, so now Kc value is given 1.15 to the power of 2, which is equivalent to 115. Huh? Okay, so the value over here, you just using what we have find in terms of X. So HF kita ada 2X raised to the power of 2. Don't forget about your normal bracket. Nah. Jangan tak letak bracket. Letak bracket sebab awak tengok dekat sini. 2x squared and in bracket 2x squared is different value. Because you need to times 2 to the power of 2 with 2x squared. So kita pakai yang ini mesti kena ada bracket. Okay, so over the value 1.0 minus x, 2.0 minus x. And to find your x value, you're using your quadratic mathematics. Pernah belajar kan quadratic?
X
Nah.
square. 115 equal to 4x squared over 2 plus
Mereka kena tukar dia di matematik pula.
plus x square. X square plus 2x plus 2 yang bawah tu.
Okay, kirakan sendiri. Okay, Madam nak tahu dia sebab ini adalah quadratic, mathematic quadratic. You will get the values of you will get two value of x. Okay, you will get two value of x. One of it cannot be used. Okay, one of it cannot be used. Why? You have to try to substitute into this x value and see what is the concentrations for all of these species. Okay, remember the equilibrium, the concentration cannot be negative. If you get a negative value, that means that x value is wrong. Okay, so these two values, you're going to calculate, substitute back into the x value here, calculate. Only possible value will be accepted, yeah, for the concentrations at equilibrium. Okay, so for this one, I think you are going to take times to solve your quadratic calculation. So I will stop over here. And for our next hour, Madam nak check awak punya jawapan.
Madam.
Yeah.
I'm not sure, but I got both of the X is positive.
Yes.
R
X,
or positive.
X value will be positive. The one that Madam
Oh,
say
okay.
cannot be negative is the equilibrium concentration. So maksudnya Hazim dapat dua value X tu kan, awak cuba substitutekan dalam equilibrium concentration dekat sini yang Madam underline. Okay. Lepas tu
Oh,
awak check.
alright.
Concentration dia tak boleh negatif. X memang dia akan dapat positif lah, tak ada masalah. Tapi cuba check bila awak buat substitution.
Alright,
Okay.
so
So, Madam hold on dekat sini and I will check your answer in the coming lesson. So, on Thursday, I think we are going to have our lessons. Sebab Thursday ni awak tak ada lab, tak ada practical session. So, I'll discuss with Encik Mazlan dululah untuk
Thursday.
MS32. Thursday.
But madam, some of us, for
Yeah.
example, myself,
Coming back.
are returning to college that day. I'm not sure about others, but I'm one of some of the students left to go to the college.
Tak apalah, Madam tengok macam mana nanti. Okay? Kalau tak
I
ada next
thought
week
you said, but I thought you
Okay,
said
Chair.
before you want to do just a video. Talk to Fizi. Oh, sorry.
tak apa. Madam akan inform nantilah. So, apa yang Madam nak in the next lesson, I want to see your answer for concentrations of species HF, F2 and HF. Okay?
Madam.
Yep.
So for this Thursday, you're not sure what we're going to do yet.
Madam akan update ya. Madam tanya
Alright.
dulu. Jangan lupa petang ini ada UPS 2. Okay.
Okay, Chair.
Set alarm jangan saya tak nak ada orang yang terlepas lah, tertidur lah. Macam
And madam.
Okay, set alarm. Yeah.
I was about to ask about the attendance.
Yes, Madam just share into your chat box. So you can click it from there. Okay. Madam nak tengok sebab setiap kali Madam tengok awak punya responses, ada yang dapat 0.4, 1.4, 0.4. Padahal soalan yang Madam tanya, we have already discussed. I have mentioned several times in the Google Meet. So kalau sesiapa yang dapat 0.4, 1.4, maksudnya awak tak join kelas. Awak hanya buka sahaja tanpa dengar. So from this time onward, siapa yang dapat kosong, beberapa soalan yang Madam bagi, I want a reasonable excuse why you got the low marks. Sebab soalan yang Madam tanya memang Madam dah explain dalam Meet. So I want you to get that idea. Kalau salah, bagi tahu reason kenapa. Apa yang awak salah faham. Kalau tak awak buka Google Meet, tak dengar apa-apa, tak catat apa-apa, main jawab je. In order to get the attendance. Okay.
So madam.
Yeah.
So if we got anything like we answered